Right, at the end of our discussion, calculating an inverse of a 2 by 2 matrix, this is what we had. Let's get pen there. We started with A, which, if I'm not mistaken, we got it as A, B, C, D. Are we together, guys? If I'm not correct, please tell me. Then we did that solution of equations, that those two system equations in terms of U and V, then X and Y. Then we got that the inverse of A was equals to, not really, let me get this, it was 1 over AD minus BC. And we agreed that that was, the denominator was actually the determinant of A. In other words, if A determinant is AD minus BC. Are we together, guys? Then in the brackets there, what was there? What was? Can you tell me what was in the brackets inside it? D minus B minus B minus C and A. Then let's stop there and pause and think in terms of what we have now as the inverse of A and the A. And just what I'm trying to say, that pause and think. Let's see what exactly happened to A. Because you see the inverse now is coming all in terms of the entries of A. Do you see that? This is not surprising, because if I had an equation like this, 2x equals to 8, and I had to solve it, I would come up with 2 to the power minus 2 and multiply there, and then I get x is equal to 2 minus 2 minus x. Is that right? So this number which I'm using here, which is the reciprocal, which in this case I can say is the inversion of what? Of 2. 2 has been inverted, isn't it? So that's the same thing. So this is exactly the same thing. The inverse of A comes in terms of the entries of A. That's not very strange. It's expected. Now, what has happened? What has happened? Just check what has happened. Just focus on what happened. This D moved over there, and the A moved over to the position of D. And then C and B were left in the same place, multiplied by -1. And then maybe certain questions they can happen. Where did the minus sign come from and all of things? That involves a long discussion to get to there. But it's a result of some kind of working with this thing and analyzing the thing. It's like that. So at the end of a very good day, if I've got a matrix here and say the matrix is 2, 3, 1, and 4, and they ask you, find the inverse, I think everybody immediately will say, what's the determinant of A? To see whether I can continue searching for inverse or not. Then I will say, this is 6 minus 4, and the determinant is 2. Because it's not equal to 0, then we can say A inverse exists. Then now I'm sure that it exists. Then I can search for something which I know that it exists, isn't it? But okay, in this case, we've been already given a formula. Then it's kind of a formula to have there. We just have to say 1 over the determinant, which is 2. Then play around with the entries like they are played around there. It's just to focus on what has happened here. What is D here? You put it there. What is D? 3. 3. What is A? It's 2. Then what is B? B is B, C is C. Then just minus 1, minus 4. I think this is it depends who says this is the easiest. This is the easiest matrix inverse, or what's called this? This is the easiest type of matrix to determine the inverse, because you can see exactly what's happening there. But things change when you start dealing with it. Higher order matrices like 3 by 3, 4 by 4, and so on. Now, just to give you a feel of what happens when you're dealing with a higher order matrices, let me show you what has happened. You agree this is an inverse, isn't it? You agree. Let me just show you something. Listen, I'm showing you something. Just try to take it as I'm showing you. Try to understand it as I'm showing you. I've got matrix A here. I'm going to come up with something which I'm going to show you and say there's something called A11. Don't refer to it as an entry of matrix at this moment. It's just something I'm naming A11. Is it? Meaning is associated with this matrix. How do I get that animal called A11? This is what I do. I come to this matrix, drop this row, drop this column. Did you see what I did? What am I left with? 3. Then I put that 3 as 3. I don't want red. I like black. Black is beautiful. I didn't say green is dead. I said black is beautiful. So don't misinterpret me. Right. Then go A, 1, 2. What am I going to do now? I'm going to what did I do now? I want to pick this line. Oh, it doesn't want me to pick the line. Let me pick. Yeah, I picked the line. Okay, I do that. Then, okay. What did I do now? I'm dropping what? A, this row and this column. Now I'm going to get 1, 2. Do you see that is the 1, 2? So what am I left with? I'm left with 1. Do you agree? I'm left with 1 then. I come next and say A, want to drop that. What am I left with? What is that? A what? A 2, 1. I'm left with what? 4. Then I come here and say that's 4. Then I come and say A. I'm left with A 2, 2. You see that? So then I pick that thing and I drop these 2. What am I left with? 2. Are we agreeing, guys? Okay, 2. Now, what am I going to create? I'm going to create a new matrix here, which I'm going to call C. No. I'm making a mistake. Sorry. Let's pardon me there. Let me get another new thing. I'm going to call C11. And this thing I'm going to create it this way. I'm telling you that I'm going to create this thing this way. Going to be minus 1 brackets 1 plus 1 multiplied by A11. Then these things here I'm going to call them minors. M-I-N-O-R-S. Those are minors, isn't it? This is what I'm creating now. I'm going to call them cofactors. Then here I'm going to end up with 3 times minus 1 to the power 2. What is that? Minus 1 to the power 2? 1. Is it? Times 3. I'll get this thing is 3. So my C11 is 3. Altogether. Then I'm going to go to my C12. What am I going to do now? I'm going to take a minus 1 and power it to power 1 plus 2, which is minus 1 to power 3 multiplied by 1. 3 negative signs will give me negative. So I'm getting this as minus 1. Then I go to C what? 2, 1. Then I'm going to multiply by minus 1 to the power 2 plus 1 is 3 again. Then multiply by what? By 4. If I come here, I multiply by that 3 negative signs, that I get minus 4. If you look at what's happening here, these numbers minus 4, you see them? You see them? They're coming. So this, what I'm doing here, is something to do with calculating an inverse of a matrix. So then I come to C 2, 2. Then I go minus 1 to the power of 4 multiplied by 2. 4 negative signs is positive. Then I can get this thing as 2. Then I'm going now to create a matrix, which I'm going to go this way. I'm going to say 3 minus 1. What is this? A11, I mean C11, C12. Do you agree? Then minus 4 and 2. That is a matrix. That is a matrix of the core factors. I can call it matrix of core factors. All together, guys. Now, just check this matrix. What is the difference between this matrix and this what I've got there? Are they different? Yes, they're different. They're not equal. But what did I do if to make them equal? What I'm going to do is what we call transposing a matrix. Call that C transpose. C, read that as C transpose. What is it to transpose a matrix? To transpose a matrix is simple to change rows to columns. What you don't change is the diagonal. And you know what to do? You rotate the rows clockwise. Now this row is hinged here. Then I rotate it clockwise. If I rotate it clockwise, I push it down, minus 1 is going to come here. Do you see that? So I'm going to have here 3 minus 1. Then when I get here, it hinges here. If I rotate it clockwise, what is this side will go down? What is that side will go up? Isn't it? So this is going to be minus 4, 2. This matrix has got a name, this one. The transpose of C is called the adjoint of our very first matrix A, where we started. That's the adjoint of A. Now, if we now look at what is happening here, to get the inverse of A, you just need to have A inverse, you need to have 1 over the determinant of A multiplied by the adjoint of A. So what is the message here? It says, in order to get, because what we did with the 2 by 2 here, this thing here, we're not going to be able to do it very easily with the 3 by 3. So now, to counter that problem, now we're coming up with this, that if you can use this kind of manipulation to get some matrix which you can call matrix of the coefficient, and then from the matrix of coefficient it transpose to get the adjoint, then you can immediately calculate what? The inverse of a matrix. Now we've got a way to calculate the inverse of a matrix. That's right. So I'm going to stop there for a while as an introduction. In our next session, what I'm going to do, I'm going to pick a matrix, for example, a matrix of 3 by 3. And it illustrates exactly what I'm saying here. Do exactly what I'm saying here. Then once you have mastered it or seen the example, you practice enough of example, then you can try to imagine what you're going to do with the 4 by 4 matrix. And imagine what you're going to do with a 5 by 5. Until you get to a stage to imagining, if you've got 100 by 100, how can I write a program on a computer to get me the inverse of 100 by 100? Because I'll need it. We'll see when we need it later. All together, guys? Okay, let me stop there and say thank you for listening.